This is Unit 4, Investigation 2, Lessons 3 and 4. We're starting you off with an entry ticket. This is going to be on your problem set so that I can see your work. Please get in the habit of differentiating between what your dividend, divisor, and quotient are. I just wanted to help you guys set this one up, and I just wanted to give you a hint / a reminder that you need to put your placeholders in whenever you have a degree that's missing. In this case, we have an x to the third and we have an x, so we're missing that x to the second degree. So that's going to be my placeholder right here, 0x squared. It doesn't change our problem, but it acts as a placeholder so that all of our work lines up. Moving on to the concept development, we're going to be doing another strategy called synthetic division for dividing polynomials. It's actually a shorter method for dividing polynomials, but you're dividing by a linear factor that's always in the form x minus k. That's really important. So we have our dividend on the left here, and we have our divisor on the right here of this division problem. Our divisor is x minus 4, so it is in that x minus k form. So if this was a polynomial that was in factored form, like for example, x minus 3 times x plus 4 is equal to f of x, well, we know that by setting each of these factors equal to 0, I'm going to find my roots. So in this situation, we get x equals 3 and x equals negative 4. So that means I'm going to have the polynomial cross the x-axis at 3, 0 and negative 4, 0. So the same thing follows for when you're dealing with division of polynomials, right? So if you have x minus 4, if you set that equal to 0, you get 4. Just like pretend for just a second, it was x plus 4. Well, if this is a factor, right, of this polynomial, then if I set it equal to 0, I can solve for the root. Well, I get x is equal to negative 4. And in this situation, then this would be a negative 4. But right now, we're going to focus on our x minus 4. And we know that if we solve for x, we get 4. So there's going to be a positive 4 right here on the left. So if you look at the dividend, underlined in red, orange, yellow, and green, the coefficients. So we're going to be taking those exact coefficients and bringing them down so that we can use them for our synthetic division. So we're not paying attention to the variable at all. We're just using the coefficients. Math comes next. Okay, so whenever you set this up, the first step that you're always going to take is to bring down this first coefficient. You don't do anything with it yet. You just bring it down. So then we take 2 and multiply by this k value. So if 2 times 4 is 8, so I get 8. Negative 7 plus 8 is a positive 1. And then again, I have to multiply by my k value, which is 4. So 1 times 4 is 4. I put a 4 there. Now I do the same exact process. Negative 8 plus 4 is negative 4. And then I have to multiply this negative 4 by that k value again, which is how I get negative 16. 16 and a negative 16 will cancel, and they'll create 0. So you actually have no remainder. So this is going to be your remainder. This is always going to be your constant. And then from there, going from right to left, it's just going to increase in degree. So this is going to be x and this is going to be x squared. So if we were to rewrite that, the quotient is 2x squared plus x minus 4. And because there's no remainder, we have plus 0. So that's why they didn't put that. Now it asks to write the dividend as a product of its factors. So the word product means you're multiplying. My dividend is the polynomial I started with. So I have, and this is going to be equal to the product, which is multiplication, of my quotient, which is multiplied by my divisor, which is x minus 4. If you distribute and solve, you're going to see that this does hold true. I'm going to let you come up with your own advantages and disadvantages. I'm going to skip down to these 2 examples of synthetic division here. And it's asking us to write our dividend for each one. So we know that our dividend is going to come from this first row because that's where we put our coefficients from our dividend to begin our problem. So we know that this is always going to be our constant. We're always going to have our constant to the rightmost. And then the degree is going to go up from there. So in this situation, we're going to have x squared, x to the third, x to the fourth. So my dividend, I'm going to write in red, is x to the fourth minus 4x squared. No need to write this 0x to the third, minus 3x plus 6. My dividend here is going to start with 2, And here I know my 6 is my constant, and it's going to go up in degree from there. So I see 1, 2, 3, 4 spots. I'm probably going to have x to the 4th power. So I'm going to have 2x to the 4th minus 4x to the 3rd minus 4x to the 2nd minus 3x plus 6. In blue, I'm going to write the divisor. So the divisor always comes from the left. It's our k value. And it's always going to be in x minus k form. So here I'm going to have x minus 2. And here I'm going to have x minus a negative 3, which is the same thing as saying x plus 3. In green, I'm going to write the quotient. So the quotient, we're going to be looking at the bottom row after all of our calculations. We have our remainder on the rightmost, and then it's going to go right to our constant. Then from that moment on, it's going to increase in degree, going to the left. Same thing here. This is my constant, x to the 3rd plus 2x to the 2nd. No need to write the 0x, minus 3. And this is my quotient. And I have no remainder, so I'm going to say plus 0, which is the same thing if I don't include the plus 0. And then over here on the right, we have 2x to the 3rd minus 10x to the 2nd plus 26x minus 81. And the difference here is you got to put the remainder. So the remainder is going to be plus, because it's a positive 249. And you're going to say 249, which is the remainder, divided by the divisor, right, which is x plus 3. On the next page, we're going to be looking at a comparison of long division versus synthetic division. So the first question, I'm going to color code here. So in green, we know that our dividend in long division is right here. And we know that in synthetic division, we have just the coefficients, not the variables, but just the coefficients in this top row. So this is under the division symbol, and this is on the top row of the synthetic division process. Then it asks, and let's change to blue, where in the synthetic division do you see the value of the divisor? Well, my divisor in long division is right here to the left side, but so is my synthetic division. Divisor in both long division and synthetic division is on the left-hand side. The only difference is, like we talked about before, we're only accounting for the coefficients. What other connections can you make between these two processes? Well, there's actually a couple things I do want to point out. So when you're doing your long division, it's kind of a process to subtract each term, and you have to be careful of your negatives. Here in synthetic division, it's a little bit easier because you don't have to do all this subtraction and changing of signs to make sure you're adding your terms correctly. So if we look here, I'm looking for a 6, a 3, and a 15. So they actually made a mistake here, but that's okay because it's going to be a really good example for us to fix. If I were to subtract these values, right, I'm subtracting a 2x to the 3rd. That's going to become plus a negative 2x to the 3rd. If I'm subtracting a negative 6x to the 2nd, that's just going to become a positive 6x to the 2nd. Here, I'm subtracting x squared minus 3x. I'm subtracting this value. So technically, I'm switching if I'm distributing this negative, this becomes plus a negative x squared and plus a positive 3x. If we distribute this negative, we're going to get plus a positive 5x and plus a negative 15. And here, they actually just forgot to put a negative, but that's very important. So we have a positive 6x squared, positive 3x, and a negative 15. So if you kind of see, if we look at these values, those all line up with the values that we're subtracting in the long division on the left. And one thing you need to be very careful of, just like in this example, they made a typo, right? You got to be careful with your negatives because 15 plus 15 would actually give you a remainder of 30. But because we fixed that mistake and we know that it's not supposed to be positive, we know that 15 and negative 15 will give us that 0 remainder. Lastly, this is your quotient, and you're going to be looking at this bottom row for your quotient versus kind of looking at the top in long division for the quotient. And here's my remainder, and here is my remainder. If you look and you're comparing these two, they're very similar, except one just looks a lot more simple. Now we're going to try some examples. X minus 1 as our divisor, and we have this as our dividend. So we're going to set this up. We have this x minus k form, so we know that our k value is going to be equal to 1. I'm going to set up my coefficients of my dividend. So I know I have 1x to the third, negative 3x to the second, negative 1x, and then I have a positive 3 as a constant. I'm going to bring down my first coefficient, not going to do anything with that. Then I'm going to multiply by the k value. So 1 times 1 is 1. Then I got to add these two terms, negative 3 and 1. So I get negative 2. I got to multiply by my k value again. So negative 2 times 1 is negative 2. If I add negative 1 and negative 2 together, I get negative 3. And then if I multiply negative 3 by this k, which is 1, I get negative 3. So here, 3 and negative 3 are going to give me 0. And this is my remainder. This is my constant. And I'm going to be going up in degree going from the right to the left. I know that my quotient is going to be x squared minus 2x minus 3. All right, and you can write this to help you if you need. Next example. This is a really good example to show why we need placeholders. I'm going to rewrite this as x to the third plus 0x to the second plus 0x plus 1, all divided into x plus 1. We need an x minus k form for our divisor. But here we have x plus 1. So we know that if we take x plus 1 and set it equal to 0, solving for x, we get x is equal to negative 1. Negative 1 is my divisor. Take my leading coefficients from my dividend. I'm going to get 1, 0, 0, 1. Switching colors here, we're going to solve for our quotient. So we're going to bring down this first coefficient. We're going to have 1. 1 times negative 1, which is my k value, right, is going to be negative 1. If I add 0 and negative 1, I get negative 1. I need to multiply negative 1 by k, which is negative 1. So negative 1 times negative 1 is just a positive 1. And then if I add 0 and 1 together, I get 1. Again, and then now I need to multiply by k again. So 1 times negative 1 gives me another negative 1. And here, 1 and negative 1 give you 0. So this is my remainder. My last term is this remainder. And knowing that this has to be my constant, I know that my highest degree is going to be x to the second. So my quotient is going to be x to the second minus x plus 1. And since there is no remainder, that means x plus 1 is a factor of x to the third plus 1. Moving on to entry ticket for lesson 4 review. I'm just going to go over a couple key points, right? I need you to remember that whenever you're factoring, they already factor out this 2x for you, but they're asking you to factor the quadratic that's right next to here. Moving on to entry ticket for lesson 4, this is also going to be in your problem set, but they're asking you to factor. They already factored out a 2x for you, and then they're asking you to factor out the quadratic that was remaining. So you got to factor this out, and it's going to give you 2 more additional factors. You know that when you're factoring, it has to multiply to the last constant term, right, and add to the middle term. That usually has the variable just x, and you're going to make sure that those are your roots, and you know that you can solve for your roots by setting each factor equal to 0. Then another thing I need you to be aware of and remember is that depending on the leading coefficient, so in this case it's going to be 2, that's going to change our end behavior, right? So look back at those end behavior charts that we made, and depending on what degree it has and whether a is greater than or less than 0, that's going to change our end behavior on the graph. I'm only asking for a rough sketch. Doesn't need to be perfect, as long as I know exactly what you're doing at each root and your end behavior is correct. Experimenting with the remainder theorem a little bit. So they give you a formal equation right here, but we're going to play with that in a second. First, we're going to do some direct computation. So if I'm going to do synthetic division, just because it's a little bit less work to look at it all at once. So I know that if I'm dividing by x minus 3, my k value is 3. And then I'm going to take the coefficients from the original polynomial. I'm going to bring down this negative 3. Don't do anything with it yet. Then multiply by my k value. So negative 3 times 3 is negative 9. If I add negative 9 and 5, I get negative 4. And then if I multiply again by k, which is 3, negative 4 times 3 is negative 12. So I get a negative 8 as my remainder. Then it asks me to evaluate for p of 3. 3 for x, and I know that 3 squared is 9. I know 5 times 3 is 15, and we have a plus 4 at the end. 9 times negative 3 gives me negative 27. Then I'm adding 15 and I'm adding 4. One thing I like to do is, well, I know that I can add my positive numbers first mentally really easily. So 15 plus 4 is 19. So I get negative 27 plus 19. If you think about your like terms, right, and you know that addition order doesn't matter, so you can actually switch these around. This is exactly the same thing as saying 19 minus 27, which is going to give you a negative 8. And if you notice, this is actually the same as this. Looking at another example, this example is very important because this is when our placeholders kind of come into play. I'm missing my x to the second term, so I'm going to use 0 as a placeholder for x squared. Now that I have that established, well, I also know I'm dividing by x minus 4, so my k value is going to be 4. And I'm going to use yellow again for my calculations. I'm going to bring down this 3. I got to multiply by k, so 4 times 3 is 12. 12 and negative 2 give me a positive 10. 10 times 4 gives me 40. I'm adding again, so 0 plus 40 is 40. Then I have to continue, so 40 times 4. Well, 4 times 4 is 16, and you're adding a 0, so we get 160. Adding 160 to 5, I get 165. And if I multiply 165 by 4, I get 660. Let me just extend my line over here. And then I get 660 plus 2 is 662. Well, when x is equal to 4, they asked me to evaluate when x is equal to 4. I know 4 to the 4th power is 246, so 3 times 246. 4 to the 3rd is 64, so I get 2 times 64. 5 times 4 is 20, and then I have to add another 2, so I'm just going to make that into a plus 22. 3 times 246 is 768. 64 times 2 is, times negative 2 is negative 128. And then we have our plus 22. So if you just take your calculator, take 768, subtract 128, and then you add 22, you get 662, which again is the same as you got for a remainder when you divided. I'm going to ask you to do number 3 alone on your own because it's exactly the same as the 2 we just did together. We're going to jump down to number 4. It says consider the polynomial x squared plus 2x plus 1. We need to divide it by x plus 1, and then it's asking what the remainder is. So if we just do our long division, we have x plus 1. If we set that equal to 0, x is equal to negative 1. So negative 1 is my x value. Another way to think about that, like I said before, was x minus a negative 1. That's how we get this negative 1, right? Because this is the same thing as saying x plus 1. I'm going to input my coefficients for my polynomial, so I get 1, 2, and 1. I'm going to bring down, I'm going to use yellow to bring this down. So I'm going to use yellow, I'm going to bring this first coefficient down. I'm going to multiply by k. 1 times negative 1 is negative 1. I'm going to add 2 and negative 1 just to get a positive 1. And if I multiply negative 1 and 1, I get another negative 1. And here we're going to see that we have 0 remainder. It says, what is q of x? This is asking for the quotient. Is quotient. So we're going to be looking at this bottom row, and we know that it's going to be, our constant is right here. So it's going to increase in x values and degrees of, it's going to increase in degree from right to left. So we know we're going to have x as our highest degree. So x plus 1 is our quotient. And we have 0 remainder. Now it asks, okay, well, does p of x equal q of x times x minus a plus pa. So in this situation, does p of x, which is our polynomial, right? That's our original polynomial. So it does x squared plus 2x plus 1 equal the quotient, which we have here, so x plus 1, times the divisor, right? We have x plus 1 as a divisor. And it asks us, and plus p of a, which is the remainder. So we solve for the remainder using synthetic division, but I'm actually going to change color here. And if we solved for p of negative 1, which is our k value, right? Then we would get negative 1 squared plus 2 times negative 1 plus 1. So negative 1 squared is 1. 2 times negative 1 is negative 2 plus 1. We get a remainder of 0. So we get plus 0. And as you can see again, this lines up with what we divided out. It says factor p of x, which is the original polynomial that we were working with. So if we were to factor p of x, we need something that's going to multiply to 1 and add to 2. So our only option is just 1 and 1. So if we were just to factor this without any type of division involved, we would have gotten the same exact thing as when we did the hard work and more work. What is the relationship that we discovered between dividing by a polynomial x minus a and the evaluation of p of a? From the examples that we have done, so in the first situation, we were dividing by x plus 1. In these other two examples, we were dividing by x minus 4 and x minus 3. Well, when we divided, we got a certain remainder. And then when we evaluated for that a value, or k we like to call it from before, we got the same exact remainder. Same thing with number 2. We got 662 as a remainder. If we evaluated for that factor, then we got 662 as our answer as well.